Hello, dear students, boys and girls. This is Dr. Khaleel Khan welcoming you to GFG platform and welcome on board to operating system Maha Marathon series. तो बच्चों, ये सेशन में हम डिस्कस करने वाले हैं द लास्ट पार्ट ऑफ ऑपरेटिंग सिस्टम महा रिवीजन या महा मैराथन, जहां पर हम डिस्कस करेंगे फाइल सिस्टम और इनपुट आउटपुट मैनेजमेंट या डिवाइस मैनेजमेंट, जहां पर हम डिस्कस करेंगे डिवाइस शेड्यूलिंग या आईओ शेड्यूलिंग के। ठीक है, तो चलिए स्टार्ट करते हैं विथ रिगार्ड टू फाइल सिस्टम के इम्पॉर्टेंट टॉपिक्स क्या है फ्रॉम गेट एग्जाम परस्पेक्टिव, सो दैट आप अपना रिवीजन अच्छे तरीके से कर सको। दिस इज माय एज यूजुअल टेलीग्राम चैनल। इफ यू हैव नॉट सब्सक्राइब, इफ यू हैव नॉट ज्वाइन, काइंडली ज्वाइन इट, क्योंकि यहाँ पर आपको इस सेशन का भी पीडीएफ मिलेगा और पिछले सेशंस के भी पीडीएफ मिलेंगे। ओके, खलील सर गेट। एंड जैसे मैंने कहा कि फाइल सिस्टम एंड डिवाइस मैनेजमेंट, सबसे पहले हम बात करेंगे वेयर एग्जैक्टली फाइल सिस्टम रिसाइड। ठीक है, व्हाट एग्जैक्टली इज द नीड ऑफ फाइल सिस्टम एंड वेयर एग्जैक्टली द फाइल सिस्टम रिसाइड। सो लेट अस राइट द टाइटल फाइल सिस्टम। आपको बताता चलूं कि among all the modules of operating system, the only module which is visible to human eye is file system. You cannot see process running on CPU. You cannot see process residing in main memory. You cannot see process getting scheduled, synchronization, deadlock. ये सभी कुछ आप देख नहीं सकते हो. These are all abstract things. The only thing visible to human eye is file system or file. So where does file system exactly reside and what is the need of file system? Let us try to discuss it. So imagine, for example, this is your secondary storage device like disk, and let's say this is your processor, CPU. As we know, processor is an electronic device and secondary storage disk, so imagine this is a disk, is an electromechanical device. So to harmonize the differences between the two different types of devices, हमें चाहिएगा a sort of interface. We require an interface like ID interface, 𝐂𝐤𝐬 interface, SATA interface. This is generally called the interface that will harmonize the differences between the processor and the electromechanical device like disk. And to run this interface, we require a software, device specific software, which is generally called device driver. A device driver. And to manage this device driver, essentially you require a disk manager. The disk manager. So here, the disk system or disk manager, device manager software or device manager module of operating system. And in between them, there is a thin layer, you can say a thin layer of the software, which is generally called the file system. ये है file system. ठीक है? This is what is termed as file system. So that's why generally we discuss file system and device management together, because they are in unison if you are trying to observe it. So this is the architecture, this is the view. So as part of study of file system, what is essentially important is you should be well knowledgeable with regard to the disk management. So that part of CO, जहाँ पर आप disk organization पढ़ोगे, so it is required that you make a study of it if you have not done earlier. How is disk organized? I mean, there are two things that you need to learn here. One is the physical geometry of disk, physical structure, physical geometry, and the other is logical structure. Logical structure. Physical geometry का मतलब ये है कि like the disk organization in the form of platters, platters into surfaces, surfaces into tracks, tracks divided into sectors, sectors of size, sectors measured in bytes. ये organization है. Disk I/O time is the constitution of seek time, latency time and data transfer time. फिर DTR का concept है, RPM का concept है, ये सभी चीजें आप disk organization you study in the subject of computer organization. Logical structure का मतलब है the file system organization. That means when you format any disk with any file system, तो जो formatting structures create होंगे उसके बारे में आप पढ़ोगे in the logical structure. मैं थोड़ा सा यहाँ पर आपको review भी बता दूंगा what is the logical structure of the file system. तो सबसे पहले you should have a understanding with regard to the file versus directory concept. What is file? What is directory? Let us have a very quick review with regard to this. ठीक है? Generally, अगर आप देखोगे definition of file, people say file is a collection of records. Collection of records. ये तो बिल्कुल सही है. Collection of records, records of some entity, records of some aspect, right? It could be records of students, records of employee, records of books, records of account details, so on. And practically, in terms of implementation, you can say that file is generally implemented or treated as an ADT, abstract data type. And being an abstract data type, जैसे हमने process में देखा था कि being an abstract data type, it will have its own definition, will have its own representation or structure, and will support a well-defined list of operations. ठीक है? And will be associated with a well-defined list of attributes. ये चीजें याद रखना है. अभी थोड़ी देर में आपको बताऊंगा मैं in the next slides what are the attributes and operations that we perform on file. उसी तरह what is directory? Generally people say directory contain files, but essentially I would say directory is also a special file. It's also a special file. And being a file, it contains information about file, and that is nothing but metadata. So invariably आप कह सकते हो directory is nothing but a file containing metadata of other files which are there as part of directory. And conceptually, you can view directory like a linear one-dimensional array, for example. This is like a abstract view of directory. Okay? These are called directory entries. Directory entries, where we say one entry per file. One entry per file. Okay? And traditionally, there are different directory structures. So if you talk of different ways of organizing directory structures, different types of directory structures. I mean, थोड़ी सी familiarity कर लेना चाहिए आपको. Like for example, अगर आपके detail lectures में देखा होगा तो you can have one level directory structure, or you can have two level directory structure, or you can have a tree structured directory. ठीक है? Or maybe for example, you can even have general graph directory structure, DAG, directed acyclic graph directory structures. Several directory structures will be there. And now coming to the concept of file, you can check here, collection of logically related records of some entity. File as an entity is associated with attributes. These are some of the attributes: name of the file, allocation of file, permission, file type, generation time, owner, author, file size, last modified, and password. Boys and girls, आपको कहना यह है कि these are called the general attributes of the file. I mean, I consider like this. These are general attributes. इनके अलावा, apart from general attributes, the file will also be associated with something called location attributes. Location का मतलब ये है कि where is the file located, right? Like in the form of path name plus, of course, path यहाँ पे आ गया है already. Suppose if not, location of the file. So location attributes में generally I would recommend that you should remember blocks in use. What are the blocks of the disk that are in use by the file? That is important attribute of the file as part of location. तो मैं इसे सब categorize कर रहा हूँ. Then what are the file context? So file context is nothing but the file attributes which are stored in a table called FCB. जिस तरह we have PCB, process control block, उसी तरह we have file control block. Like process control block contain the attributes of process. File control block contain attributes of file. File control block is known by different terms in different OS. Like example कह रहा हूँ, in Unix and Linux operating systems, file system is popularly called, आपको पता है, inode, index node. And in other operating system, it is directory entry. Like file have various types. These are types of files: doc file, executable file, .png, .mp3, and several other types. Then what are the operations generally that you carry out on file? Various operations like create the file, open the file, read from file, write to the file, seek to the file. copy the contents of the file, cut the contents of file, print the file, paste the file, save the file, right? Then so many attributes, and then finally delete the file and close the file. Boys and girls, let me tell you that these attributes are supported at two levels. Either you can perform these operations in the form of commands, textual commands or GUI commands, and then in other way you can perform these operations is by means of API calls or maybe system calls through programs. Either through system calls or maybe through API calls, you can perform these operations. Every operating system will provide these operations fundamentally. What are the different ways of accessing the files? I can access the files in the form of sequential access or random access or direct access. Sequential access is slow, random access is fast. That will invariably depend on the nature of the file, how it is stored. Is it stored on sequential device or is it stored on random device? Yeah, attributes. And next part which I would like to talk about is the implementation aspect of the file system. Okay, for example, imagine this is your disk. Generally, आप क्या करोगे disk को? Disk will be divided into logical units which are called partitions or volumes. Disk is divided into logical units called partitions or volumes. And you know partitions are of two types, primary and extended partitions. Primary partitions are bootable, extended partitions are non-bootable. Partitions are designated with drive letters like C:, D:, E:. हर एक partition को आपने format करना होगा with some file system. You have to format it with some file system. Okay? Like what are the various file systems generally that we use? The various file systems that we generally use, like NTFS or maybe FAT32 or maybe like ext4 or maybe Unix file system. These are the various. तो अगर जब कोई भी पार्टीशन को आप फॉर्मेट करोगे विथ एनी फाइल सिस्टम, essentially what are the important data structures that are created? यहाँ पे मैं आपको प्रेजेंट करूंगा. What are the important data structures? You will have boot control block, partition control block, directory structure, and then you will have something called data blocks. You will have data blocks. I'm just drawing randomly, okay, just for making a study. This is called the boot control block. अगर आपका partition bootable है, so this is the main booting program, the first operating system program needed for booting will be stored here, boot control block. Next is partition control block. Like agar Unix, so this is the administrative block of the disk that contains the complete details of the partition. जैसे कि what is the size of partition, how many blocks are there in the partition, how many blocks are in use, how many blocks are free, how many blocks are bad. So as such, the whole administrative information of the partition is kept here. अगर ये partition control block corrupt हो गया, मतलब आपकी disk is gone, disk is damaged. Then partition control block, like for example in Unix file system, it is called super block. Unix environment, it is called super block, or DOS or Windows में आप इसे कहोगे master file table या file allocation table. And the next is the directory structure. So boys and girls, this is just like your S area as you see in the main memory. It's just like S area. And this is like your U area. Of course, ये disk के है, हम generally नहीं करते, आपकी understanding के लिए कह रहा हूँ, just for understanding. So जो ये these are called the disk blocks. These are called the disk blocks. These are called the disk blocks. And to tell you that every disk block, यहाँ पर हम खोलेंगे. Like for example, imagine this is a disk block. I write disk block in short as DB. तो जो भी डेटा स्टोर करोगे आप on disk, it will be stored in the form of blocks. Block is the unit of allocation. Whether you store a file, whether you store a directory or any other data structure on disk, everything on disk will be stored in the form of blocks, one or more blocks. Block is a unit of allocation. And there are two important attributes that a block is associated with. One is called DBA and the other is called DBS. DBA stands for disk block address. And DBS stands for disk block size. ठीक है। जनरली एड्रेस इज मेजर्ड इन बिट्स, हालांकि आप बाइट्स में भी कन्वर्ट कर सकते हो, बट जनरली मेजर्ड इन बिट्स एंड साइज ऑब्वियसली विल मेजर्ड इन टर्म्स ऑफ बाइट्स। अगर बिट्स हो तो बाइट्स में कन्वर्ट कर सकते हो, बाइट्स हो तो बिट्स में कन्वर्ट कर सकते हो। मैक्सिमम पॉसिबल डिस्क, ये दोनों पैरामीटर्स पर आपके क्या बनेगी, मैक्सिमम पॉसिबल डिस्क साइज, मैक्सिमम पॉसिबल डिस्क साइज आपकी होगी 2 power dBA, where dBA is in bits multiplied by, this will give you number of blocks and multiplied by block size. ये है formula, remember. Assuming dBA is in bits, 2 power dBA will give you the number of blocks possible multiplied by dBS in bytes. So this will give you maximum disk size. अब जो सबसे पहले हमें जो हमें स्टडी करना है वो है एलोकेशन मेथड्स। अगर कोई फाइल आप स्टोर करना चाह रहे हो तो आप कैसे स्टोर करोगे, हाउ डू यू एलोकेट ब्लॉक्स टू द फाइल। सबसे पहले आपने डिटरमिन करना होगा हाउ मेनी ब्लॉक्स आर नीडेड फॉर द फाइल। लाइक अगर फाइल ब्लॉक साइज 1 KB है, फाइल की साइज 10 KB है, आई नीड 10 ब्लॉक्स। अगर ब्लॉक साइज 2 KB है, अगर आपको फाइल की साइज है 11 KB, यू नीड 6 ब्लॉक्स, 12 KB। ठीक है, इस तरीके से। तो हाउ दीज 6 ब्लॉक्स और 10 ब्लॉक्स आर टू बी एलोकेटेड, जस्ट लाइक मेमोरी मैनेजमेंट में you have allocation methods like contiguous and non-contiguous, उसी तरह यहां पर भी we have allocation methods like contiguous, linked and index. So एक के बाद एक स्टडी करेंगे। The first approach is called contiguous allocation. तो contiguous allocation में कुछ ऐसे होगा, सुनिएगा, whatever blocks that you want to allocate to a file, they should be contiguous. Like for example, in the directory structure है, देखिएगा, there is a file by name abc.doc. Its starting address is 2, that means first block in use is 2. And how many blocks are used? 4 blocks. So matlab 4 contiguous blocks starting from 2 are in use by the file, namely block number 2, block number 3, block number 4, block number 5. ये है contiguous. तो जो भी blocks आप allocate करना हो वो contiguously allocate करेंगे. Like there is another file starting 𝐂𝐻𝐧𝐤𝐬. Starting from 9, 5 blocks are in use. So कौन से blocks? 9, 10, 11, 12, 13. ये है philosophy of contiguous allocation. तो अब यहां के इसका परफॉर्मेंस क्या है, कॉन्टिग्यूअस एलोकेशन के लिमिटेशंस, एडवांटेजेस क्या है, एक के बाद एक स्टडी करेंगे। सबसे पहले इंटरनल फ्रैगमेंटेशन। क्या कॉन्टिग्यूअस एलोकेशन में इंटरनल फ्रैगमेंटेशन की पॉसिबिलिटी है? हाँ सर है। लास्ट ब्लॉक मे नॉट बी फुल्ली यूटिलाइज्ड, सो इट मे गो वेस्ट बिकॉज एट ए टाइम वन ब्लॉक विल बी इन यूज बाय ओनली वन फाइल। So if the last block is not in use fully, it will go waste in the form of internal fragmentation. So it may have internal fragmentation. It may have external fragmentation, क्योंकि अगर मान लीजिए for example these 2 blocks are free, likewise here 3 blocks are free, here 2 blocks are free, something like this. So as such, if you observe, I have 2 plus 3, 5 plus 2, 7 blocks are free, 7 free blocks. But the maximum number of free blocks that are contiguously free are 3. अगर मुझे एक फाइल क्रिएट करना है with 5 blocks, it's not possible. क्यों? हमें 5 blocks contiguous चाहिए, and I don't have 5 contiguous blocks, imagine. So therefore this approach may suffer from external fragmentation also, may suffer from external fragmentation also, is it not? So it has internal fragmentation, it has external fragmentation. Increasing the file size may be a limitation, may be inflexible here, क्योंकि next contiguous blocks free रहना जरूरी नहीं है। So उसके लिए मुझे alternatively I will have to search at other place where I have free blocks and relocate the file to a different location. That may be a time consuming operation. So therefore overhead ज़्यादा हो जाएगा. So that's what I have written here. Increasing the file size may not be possible always. May not be possible लिखना गलत है. It is inflexible, that is more appropriate. So it supports both sequential and random access. So therefore it is faster access. तो बच्चों इसका सिर्फ एक ही एडवांटेज ये है कि इट सपोर्ट डायरेक्ट एक्सेस या फास्टर एक्सेस. दैट्स द ओनली एडवांटेज ऑफ कॉन्टिग्यूअस एलोकेशन. टू सर्कमवेंट, टू ओवरकम दीज प्रॉब्लम्स, वी कैन थिंक ऑफ गोइंग इन फॉर लिंक्ड एलोकेशन. लिंक्ड एलोकेशन ये नॉन कॉन्टिग्यूअस है, नॉन कॉन्टिग्यूअस एलोकेशन. इट इज ऑल्सो कॉल्ड लिंक्ड एलोकेशन. ठीक है. The blocks which are in use may not be contiguous. लिंक लिस्ट की तरह आप एलोकेट करोगे. कोई भी कहीं भी फ्री ब्लॉक होगा तो आप यूज कर सकते हो नॉन कॉन्टिग्यूअस और लिंक्ड एलोकेशन. ठीक है. तो देखिएगा, there is a file by name abc.docx, starting address is 2, ending dba is 1. तो मतलब ये फाइल देखेगा it is growing like this 2 pointing to 6 5 and then 1. So every block में आपने pointer store करना है pointing to the next data block in use by the file. ये है philosophy of linked allocation. So every block is associated with starting DBA and ending DBA. Starting address and ending address. Linked list with starting address and ending address. क्या यहां इंटरनल फ्रैगमेंटेशन हो सकता है? हाँ सर, बिल्कुल हो सकता है. लास्ट ब्लॉक अगेन मे नॉट बी फुल्ली यूटिलाइज्ड, सो इट मे सफर फ्रॉम इंटरनल फ्रैगमेंटेशन. बट इज देयर एनी पोटेंशियल पॉसिबिलिटी ऑफ हैविंग एक्सटर्नल फ्रैगमेंटेशन? नहीं. यहां एक्सटर्नल फ्रैगमेंटेशन नहीं होगा बिकॉज एनी ब्लॉक विच इज देयर एट एनी प्लेस कैन बी यूटिलाइज्ड. नो एक्सटर्नल फ्रैगमेंटेशन. What do you say with regard to increasing file size? Always flexible. As long as free blocks are available, आप फाइल साइज इंक्रीज कर सकते हो, ये भी एडवांटेज है. लेकिन इसका ड्रॉबैक ये है कि सम अमाउंट ऑफ डिस्क स्पेस विल गो वेस्ट इन द फॉर्म ऑफ पॉइंटर्स एंड वल्नरेबिलिटी ऑफ पॉइंटर. अगर लिंक ब्रेक हो जाए, फाइल गेट ट्रंकेटेड, ये ड्रॉबैक है. राइट, सो दैट इज द रीजन व्हाई वी आर स्टोरिंग एंडिंग डीबीए टू नो द कंसिस्टेंसी ऑफ द फाइल एक्सेस. So it supports only sequential access, no random access. So therefore it is slow access. It is slow access. So ये है linked allocation. And then finally the third allocation method is called index allocation. Just like your chapter book index, उसी तरह यहाँ पर you have linked allocation. Sorry, index allocation. What happens here is every file is associated with an index block. What will the index block contain? Index block contain the addresses of the data blocks in use by the file. जो भी blocks file के use में हैं, उनके addresses आप index block में store करोगे. Like this. There is a file abc.docx. Its index block is block 4. So one of the block of the disk, block 4 is index block. यहाँ पर is block 11, block 3, block 7, block 10. These are the blocks in use. These are the addresses of blocks which are in use by the file. And -1 का मतलब end of file. तो ये है index allocation. So with one index block you can have a limitation on the file size that you can access. अगर आपकी file size और बढ़ रही है, then you can have a linked list of index blocks. तो ये philosophy है. और इसका performance वही रहेगा कि there is no external fragmentation but internal fragmentation may exist. Right? All disk block addresses of the file are at one place, so therefore it can support both sequential and random. Right? अगर file की size बहुत छोटी हो, then it may lead to wastage of the entries in the index block. Right, just to store the addresses. So that is the advantage. Reliability comparatively is better in terms of linked allocation for index allocation. अब जो index allocation है, इसका एक case study है in the case of Unix operating system. Unix or Linux operating system is based on index multi-level index organization. So Unix का inode structure देखो, ये काफी important topic है boys and girls. From examination perspective, this is a super duper important topic. You can expect some problems on this. We write the title as Unix inode structure. Okay? Unix inode structure. ठीक है? So this is the title, Unix inode structure. So it is divided into two parts. I have the general attributes here, boys and girls. Please observe, these are general attributes. Like I have data blocks, disk block size, location, reference unit, date and time, and all that general attributes. Location attributes will have basically information about the blocks in use in a different way. So first section we have direct disk block addresses, means we store the addresses of those data blocks which are in use by the file directly, direct addresses. So here this block contain data, this block contain data, this block contain data blocks. So अगर file size is more than what is possible with direct disk block addresses, then you go for a single indirect. Single indirect मतलब it will hold the addresses, it will hold the address of a block here, like your index node concept, index allocation. So this is the address of block X in single indirect, block X. And this in turn will contain the addresses of data blocks. This will contain the addresses of data blocks. उसी तरह डबल इनडायरेक्ट, 2 level indexing, first level, second level. First level contain addresses of next level index blocks, next will contain the addresses of data blocks. ये है आपका data blocks. These are data blocks. So accordingly you can find the maximum file size. मैं एक प्रॉब्लम लेकर आपको बताऊंगा कि फाइल साइज आप कैसे मेजर करते हो यहाँ, ठीक है. And before I take up the problem, I would like to also touch upon another important implementation aspect of file system design, और वो है free space management, जहां से आप expect कर सकते हो questions. How to keep track of disk blocks which are free? What are the algorithms for keeping track of free blocks? Like for example, I have a disk of size 20 MB. If I am formatting the disk into blocks of size 1 KB with an address of 16 bits, तो कितने blocks लगेंगे? Number of blocks आपके बनेंगे 20K, because size of the disk 20 MB divided by block size will give you number of blocks. So boys and girls, initially all these 20K blocks are free. Initially all these are free. तो हमें यह देखना है, how are we going to keep track of these free blocks? How are we going to keep track of these free blocks? So first algorithm is called free list approach. Free list. Here we are going to have a linked list of blocks. ये blocks है, linked list of blocks that contain addresses of free blocks. So these are all the addresses of free blocks. जैसे ही ये fill up हो जाएगा, I will take a pointer pointing to the next, take a pointer इस तरह, free list, linked list of free blocks, blocks containing addresses of free blocks, linked list of free blocks, blocks containing addresses of free blocks. ये है free linked list approach. The other approach is called bitmap approach. Bitmap approach. Sometimes people call bitmap, sometimes people call bit vector. Both are correct. So here what happens is, associated in bitmap, every disk block is associated with one binary bit indicating whether the block is in use or block is free. Every block is associated with a bit indicating whether the block is in use or block is free. जैसे कि हमारा bitmap ये है, this is the address of blocks, this is the status of block 1, block 2, block 3, block 4, 5, 6, like that. 0 means free, 1 means not in use. 0 is free, 1 is in use. So I have a map of bits. तो हम यहाँ पे कैलकुलेट कर सकते हैं कि टू स्टोर अवर बिटमैप कितने ब्लॉक्स लगेंगे स्टोर करने के लिए. आई नीड 3 ब्लॉक्स, बिकॉज 1 ब्लॉक कैन स्टोर 8 किलो बिट्स. 20 किलो बिट्स के लिए कितने ब्लॉक्स लगेंगे? 2.5. तो 2.4 और 2.5, सो आई नीड 3 ब्लॉक्स. ये है बिटमैप अप्रोच. तो कुछ प्रॉब्लम्स लेकर सॉल्व करेंगे. थोड़े क्वेश्चंस मैं आपको एज ए होमवर्क भी दूंगा. ये देखेंगे प्रॉब्लम. लेट अस ट्राई टू वर्क आउट. The index node inode of a Unix like file system has 12 direct, 1 single indirect, 1 double indirect. The disk block size is 4 KB. Boys and girls, I am solving the problem. Be careful. Disk block size is 4 KB. And the disk block address is 32 bits. So disk block address is 32 bits. 32 bits का मतलब ये हुआ 4 bytes. तो सबसे पहले आपने कैलकुलेट करना है कि एक ब्लॉक जो है डिस्क का, like this is the block of the disk. So it can store how many addresses, because that is needed for the calculation. How many addresses? So 4 KB is the size of block. Address का size है 4 bytes. So one block can store how many addresses? 4 KB by 4 bytes. 1K. One block can hold 1K addresses. तो चलिए अब maximum file size पूछा गया है, कैलकुलेट करेंगे. With direct addresses you can access how many addresses? 12. साइज ऑफ द ब्लॉक 4 KB. ये डायरेक्ट एड्रेस से आप एक्सेस करते हो. सिंगल इनडायरेक्ट से कितना कर सकते हो? 1K एड्रेसेस ईच पॉइंटिंग टू ब्लॉक ऑफ साइज 4 KB. तो 4 KB. डबल इनडायरेक्ट में 1K पॉइंटिंग ईच वन टू 1K. सो 1K इनटू साइज ऑफ द ब्लॉक 4 KB. ये आपकी मैक्सिमम फाइल साइज है. सो दिस इज 48 KB. दिस इज 4 MB. और ये बना देखिएगा किलो इज मेगा 4 GB. So this 4 MB and 48 KB is very small in front of this. Roughly I can say the size of the file is 4 GB. So he's asking the question in terms of GB. How many GB? So answer is 4. Means answer is C. That's it. Very simple question. इस तरीके के क्वेश्चन प्रैक्टिस कीजिएगा with regard to Unix inode structure. ये एक theoretical question है. In a file allocation system, which of the following allocation schemes can be used if no external fragmentation is required? कॉन्टिग्यूअस में एक्सटर्नल फ्रैगमेंटेशन होगा, हाँ होगा, लिंक्ड में होगा, नहीं होगा, इंडेक्स में होगा, नहीं होगा. सो हियर इन लिंक्ड में नहीं होगा, इंडेक्स में नहीं होगा एक्सटर्नल फ्रैगमेंटेशन. तो आंसर इज 2 and 3. सो ऑप्शन डी इज करेक्ट. ये होमवर्क की तरह ट्राई कीजिएगा, बेस्ड ऑन फैट ऑर्गेनाइजेशन है, आप ट्राई कर सकते हो. ठीक है, ये भी एक आप ट्राई कर सकते हो. व्हाट इज द साइज ऑफ द यूनिक साइनोड स्ट्रक्चर के ऊपर ही क्वेश्चन है. इसका आंसर आपको आएगा 35 किलोबाइट्स. यू कैन ट्राई इट, ओके, एज अ होमवर्क. ये एक थियोरेटिकल क्वेश्चन है, देख लेते हैं. यूजिंग लार्जर ब्लॉक साइज इन अ फिक्स्ड ब्लॉक साइज फाइल सिस्टम. मतलब अगर ब्लॉक साइज आपका लार्ज हुआ तो देयर आर टू पैरामीटर्स व्हिच यू आर मेजरिंग, स्पेस यूटिलाइजेशन एंड थ्रूपुट. ब्लॉक साइज जैसे बढ़ेगा, इंटरनल फ्रैगमेंटेशन बढ़ेगा, तो स्पेस यूटिलाइजेशन पुअर होगा. लेकिन थ्रूपुट क्या होगा? अगर ब्लॉक साइज लार्ज है तो यू कैन रीड लार्जर अमाउंट ऑफ डेटा, सो थ्रूपुट विल बेटर. सो देयरफॉर द करेक्ट आंसर इज ए, बेटर डिस्क थ्रूपुट बट पुअर डिस्क स्पेस यूटिलाइजेशन. ठीक है. So the data blocks of a very large file in the Unix file system are allocated using what? Is it contiguous or linked or index? No, it is an extension of index allocation. So therefore, extension of index allocation. What is IO redirection? IO redirection का मतलब है bypass. Generally, a process is associated with some standard files like stdin, stdout, stdr. लेकिन आप redirect करोगे तो मतलब यह है कि it can read the data from an alternate source other than standard. That is called redirection or bypass. So therefore, it can be employed to use an existing file as an input file rather than the standard file. तो ये था बच्चों with regard to file system important topics. अब लास्ट में हम टेक अप करेंगे द टॉपिक ऑन डिस्क शेड्यूलिंग. जिस तरह सीपीयू शेड्यूलिंग है उस तरह डिस्क शेड्यूलिंग है, क्योंकि अगर एक डिवाइस है, डिवाइस में डिवाइस की क्यू रहेगी, पेंडिंग रिक्वेस्ट आएंगे मल्टीपल प्रोसेसेस के, लेकिन लाइक प्रोसेसर डिस्क कैन सैटिस्फाई द रिक्वेस्ट ऑफ ओनली वन प्रोसेस, ओनली वन प्रोसेस. तो हम देखना है व्हाट आर द पोटेंशियल पॉसिबिलिटीज, वेराइटीज ऑफ सैटिस्फाइंग द प्रोसेस रिक्वेस्ट. और जो प्रोसेस के रिक्वेस्ट आएंगे, it may be for some track, it may be for some cylinder, it may be for some sector. So how does it satisfy the request? So that is a need for disk scheduling. तो वेरियस डिस्क शेड्यूलिंग टेक्निक्स जो आपने पढ़ना है फ्रॉम एग्जामिनेशन परस्पेक्टिव, जिसके बेसिस पर क्वेश्चंस आए हैं, वो है FCFS. ठीक है. एंड देन यू हैव बेसिकली लाइक शॉर्टेस्ट सीक टाइम फर्स्ट, SSTF. एंड देन यू हैव एल्गोरिथम लाइक स्कैन and a variation of scan called loop, and still a variation of scan which is called circular scan, and lastly you have something called circular loop. ये सारे के सारे शेड्यूलिंग टेक्निक्स मैं आपको बताऊंगा वन बाय वन. राइट, लेट अस ट्राई टू टेक अप द डिस्कशन ऑन द वेरियस डिस्क शेड्यूलिंग टेक्निक्स. उनका थियरी यहाँ पर है, आप देख सकते हो. उसके एडवांटेजेस एंड ड्रॉबैक भी मैंने बताया है. पहले हम थोड़ा स्टडी कर लेंगे विथ रिगार्ड टू डिस्क शेड्यूलिंग टेक्निक्स. आई विल टेक अ सैंपल डेटा सेट. Like for example, if I take the following data sets, let's say these are the process requests. These are the process requests in FIFO order. FIFO order में ये request है. Like process 1 want to read something from track number 98, and then another 183, process P2. P3 want to read from track number 37. ठीक है. And then 122, फिर उसके बाद 14, 124, फिर 65, 67. ये है प्रोसेस रिक्वेस्ट. तो डेटा आपको इस तरीके से दिया जाएगा एग्जैक्ट. ओके, द डेटा विल बी गिवन इन द एग्जाम इन द फॉलोइंग वे. Okay, so let's see this. Now for this data, you should also be given some other parameters. Like for example, we imagine we are having a disk which is sequentially numbered from tracks 0 to 199. These are the tracks. And let's say half a mark, this is something like 100, this is something like 50, this is like 150. And initially, let's imagine the read-write head is placed at track number 53. तो हमें ये स्टडी करना है how are we going to satisfy these requests in different ways. So I will show you the different scheduling techniques, how they will basically satisfy these requests. So सबसे पहले जो एल्गोरिथम है वो नेचुरल एल्गोरिथम है जिसे हम कहेंगे FCFS, फर्स्ट कम फर्स्ट सर्व. तो जिस ऑर्डर में प्रोसेस रिक्वेस्ट आए हैं उसी ऑर्डर में आप सर्व करोगे रिक्वेस्ट को, उसी ऑर्डर में आप रिक्वेस्ट को सर्व करोगे, FCFS. So for let us mark these requests 98. So here I have 98. So it will go from 53 to 98. From 98 it will go to 183. Imagine for example 183 is here, so it will go to track number 183. ठीक है? 183 से कहाँ आएगा? 37 पर आएगा. 37. So maybe 37 you imagine is here. So it will come to 37. And from 37 it will go to 122. Imagine 122 is here. From 122 it will come to 14. Perhaps 14 is here. और 14 के बाद 124 पर सर्व करेगा. So this is 124. So it will satisfy this request. And then it will go to 65. Perhaps 65 is here. And lastly, it will serve 67. तो ये है the movement of read write head in serving the request based on FCFS. तो जो मेट्रिक आपको पूछा जाएगा फॉर कंप्यूटेशन वो है नंबर ऑफ रिकॉर्ड मूवमेंट्स, नंबर ऑफ सीक्स, हाउ मेनी सीक्स आर रीड राइटेड. That means sum of all the line segments. 183 minus 653, 183 minus 37 plus 122 minus 37 plus 122 minus 14 plus 124 minus 14 plus ये पूरे लाइन लेंथ ऑफ लाइन सेगमेंट्स अगर आप कैलकुलेट करो टोटल 6 लगेगा. I think roughly this will come to 646 for first come first serve. हमारा ऑब्जेक्टिव क्या होना चाहिए? जैसे सीपीयू शेड्यूलिंग में हमारा ऑब्जेक्टिव है टू मैक्सिमाइज द सीपीयू यूटिलाइजेशन, मिनिमाइज द एवरेज सीक टाइम, एवरेज रिस्पॉन्स टाइम या वेटिंग टाइम. उसी तरह डिस्क शेड्यूलिंग में हमारा ऑब्जेक्टिव होगा टू मिनिमाइज द एवरेज सीक टाइम या टोटल सीक टाइम. वो पॉसिबल है व्हेन यू मिनिमाइज द नंबर ऑफ सीक्स. सो क्वेश्चन इज आप किस ऑर्डर में सर्व करोगे these requests so that the number of seeks get minimized, and that algorithm is called as second one, shortest seek time first. Shortest seek time first. Popularly we write in short SSTF. इसका और एक नाम है closest track next, nearest cylinder next. Closest track next और nearest cylinder next. उस ऑर्डर में आप सर्व कर सकते हो. मतलब ये है आपने ग्रीडी एल्गोरिथम अप्लाई करना है, ग्रीडी स्ट्रैटेजी अप्लाई करना है. फ्रॉम द करंट पोजीशन यू शुड गो टू दैट ट्रैक विच इज नियरेस्ट. तो मैं यहीं पे वर्क करूंगा. आई विल रिमूव इट बिकॉज फिर से पूरा डेटा कॉपी करना विल बी अ टाइम कंज्यूमिंग ऑपरेशन. आई विल रिमूव ऑफ दिस एंड आई विल वर्क आउट नाउ यूजिंग एफ शॉर्टेस्ट सीक टाइम फर्स्ट. हाउ डज इट वर्क? सो लेट्स प्रोसीड. बॉयज एंड गर्ल्स प्लीज हैव अ लुक. वी आर एट ट्रैक नंबर 53. तो किस ऑर्डर में हम सर्व करेंगे रिक्वेस्ट सो दैट आई सैटिस्फाई shortest seek time first. So from 53, the nearest is 65. 65, nearest is 67. 67 के बाद दो possibilities है, 98, 37. 37 is nearest. Then 37 से हम 14 पे जाएंगे. 14 के बाद naturally होगा 98. 98 के बाद naturally होगा 122, फिर 124. ठीक है? फिर उसके बाद satisfy करोगे 1. ये मूवमेंट है रीड राइट हेड का यूजिंग शॉर्टेस्ट सीक टाइम फर्स्ट, SSTF. Sum of these three line segments 67 minus 53 plus 67 minus 14 plus 183 minus 14, ये तीन length of segment will give you total number of seats. I think that will come to ये first come first serve. I think it was 640 अगर आप calculate करो, and for this I think it will come like 246 या 236 something like that. You can check total number of seats. तो ये है shortest seek time first. Then as I said, there are other variations. Like the third algorithm is called scan. Sometimes people also call it like elevator, just like a lift in multi-storied building going from top to bottom. Here also in the same way, the read-write head will serve the request just like an elevator, just like a lift as in multi-storied building. So I'm making a trace for the algorithm scan. Please have a look. Scan algorithm apply करने के लिए, apart from knowing the current position of read-write head, you should also know in which direction the read-write head is moving. Is it moving in higher number tracks or lower number tracks? So let's imagine it is moving in higher number tracks. So मतलब 53 is higher number tracks. So what happens? It will satisfy 65, then 67, then it will satisfy 98, then 122, then 124, then 183, then it will go to the end. और उसके बाद फिर वो रिवर्स में आएगा and then satisfy the request in this order 37 and 14. ये है the movement of read-write head based on scan algorithm. Yes, scan. तो आप कैलकुलेट कर सकते हो 199 minus 53 plus 199 minus 14. ये है number of seeks. This is number of seeks for scan. 199 minus 53 plus 199 minus 14. इसका ड्रॉबैक आप देख सकते हो कि इट इज अननेसेसरली गोइंग फ्रॉम 183 टू 199. इमेजिन अगर 1000 ट्रैक्स होते तो 183 से 1000 तक आप जाओगे, तो इट इज मेकिंग अननेसेसरी मूवमेंट. टू ओवरकम दैट प्रॉब्लम वी हैव अ वेरिएशन ऑफ स्कैन, दिस इज कॉल्ड लुक. दैट इज कॉल्ड लुक एल्गोरिथम. तो लुक एल्गोरिथम में क्या होगा? It works like scan, except that we say it looks up to the last request moving in the current direction. Last request. Look up to the last request and take reverse sweep, and thereby avoid going up to unnecessarily the last track. तो look variation में क्या होगा? यहीं पे हम change करेंगे. So it will go only up to the last request. क्या है last request? Last request is 183, and then take a reverse sweep, and then take a reverse sweep. ये है look. यह है लुक. ये लुक है. लुक अप टू द लास्ट रिक्वेस्ट 183. The number of seeks are 183 minus 53 plus 183 minus 14. थोड़ा ऑप्टिमाइजेशन. उसके अलावा there are other variations of scan which are just like, for example, circular scan, C scan. Circular scan. Circular scan में होता यह है कि the read-write head is assumed to be in, the disk is assumed to be in the form of a circular cylinder, and the read-write head is making a circular motion. That is 53 to 199 जाएगा. 199 के बाद we imagine it is getting initialized at 0, and then it makes circular motion. तो circular scan से ये request कैसे सर्व होंगे यहाँ पर हम ट्राई करेंगे. तो please follow carefully. I'll show with a different ink. Let's see. Circular scan. 53 से 65 लेगा, 65 से 67 लेगा, 98 लेगा, 122, 124, 183, फिर 199. 199 से क्या होगा? It get reinitialized at 0 by making a reverse sweep. It initializes at 0. ठीक है? और यहां आने के बाद then it will satisfy 14 and then 37. ये है movement of read write head. ये है movement of read write head. तो how many seeks are made in circular scan? Let me write as an equation. तो यहां पर देखिएगा 199 minus 53 plus 199 minus 0 याद करना होगा, प्लस 37 माइनस 0. ये है सर्कुलर स्कैन का मूवमेंट. पीपल अगर आप ऐड नहीं करोगे 199 माइनस 0, अगर बाई मिस्टेक आप ऐड नहीं करोगे तो गलत हो जाएगा. तो यू हैव टू ऐड 199 माइनस 0, रिवर्स स्वीप. तो दिस सर्कुलर स्कैन. इसी का वेरिएशन अगर आप देखोगे तो होगा सर्कुलर लुक. तो सर्कुलर लुक में वही ऑप्टिमाइजेशन होगा. इट वोंट गो अप टू 199, इट विल इंटेलिजेंटली गो अप टू 183 एंड इट विल गेट रीइनिशियलाइज्ड एट 10 रादर देन रीइनिशियलाइजिंग एट 0. वो है सर्कुलर लुक. तो चलिए स्टार्ट करेंगे सर्कुलर लुक. हाउ डज इट वर्क? लास्ट एल्गोरिथम सर्कुलर लुक बता रहा हूं, गौर से सुनिएगा प्लीज. देखिएगा प्लीज. I'm working for circular loop, boys and girls. Pay attention. So I'm at 53. 53 is 65, then 67, then 98, then 122, 124, 183. अब यहां से वो रिवर्स स्वीप लेगा, right? It will take reverse sweep and does not get initialized at 0 but get initialized at 14. ये है difference. It get initialized at 14. 14 के बाद it will satisfy 37. ये है circular loop. तो बेटा सर्कुलर लूप का मूवमेंट कितना हुआ? 183 माइनस 53 प्लस 183 माइनस 14 प्लस 37 माइनस 14. 37 माइनस 14 ये है मूवमेंट ऑफ सर्कुलर लूप. तो बॉयज एंड गर्ल्स, दीज आर द डिफरेंट 6 डिस्क शेड्यूलिंग टेक्निक्स. आप अच्छे प्रैक्टिस कीजिएगा. काफी क्वेश्चन पूछे जा चुके हैं. सम ऑफ द प्रैक्टिस क्वेश्चंस आई एम गिविंग इट फॉर यू हियर. यू कैन चेक. दीज आर द कंपैरिजंस ऑफ द डिफरेंट शेड्यूलिंग टेक्निक्स. बाद में आप देख सकते हो. एंड दीज आर सम प्रैक्टिस क्वेश्चन. दीज आर वेरी सिंपल. आप बहुत आसानी से कर सकते हो. I want each one of you to take up these questions and work out as a matter of practice. These are very, very direct, and as a matter of practice, you can solve all of them. All of them. ठीक है. एक और लास्ट टॉपिक है थ्रेड्स के बारे में आपको बताता चलूं, क्योंकि ये भी टॉपिक हमने डिस्कस नहीं किया था. इंपॉर्टेंट टॉपिक बताऊंगा. थ्रेड इज नो मोर डिफरेंट देन प्रोसेस एक्सेप्ट फॉर फ्यू केसेस. थ्रेड का स्टैंडर्ड डेफिनेशन है, इट्स अ लाइट वेट प्रोसेस. It is called lightweight because it is part of the process. It shares the address space of the process. All threads of the same process share a common address space. अगर ये आप इमेजिन कीजिए प्रोसेस है और ये इसका एड्रेस स्पेस है, where it has code section, data section, heap section, etc. Right? Code plus data plus heap section. Then if I have multiple threads, T1, T2, T3, then all of them will share the common address space. That is the main advantage. Each thread, like a process, is having its own set of independent attributes which are kept in TCB, thread control block. So each thread will have its own thread control block. Each thread will have its own thread control block, TCB. Like process control block contain the attributes of process, thread control block contain the attributes of threads. But generally, the volume of information kept in TCB is less than the volume of information kept in PCB. This will facilitate faster context switches, so therefore it will have less context switch overhead. तो जो major benefits है threads के, वो है resource sharing, economical design, right, faster context switching, and can exploit multi-core architectures, multi-processor architectures, क्योंकि multiple threads of the same process can get scheduled onto multiple cores or multiple processors. एक और important discussion जो आपने understand करना है with regard to threads is basically like the types of threads. You have user level threads and the kernel level threads. Threads that are created and managed at the user level without taking any support of operating system, they are user level threads. Flexibility है, transparency है, ये इसके advantages है. Drawback ये है कि one user level thread need to go for IO operation or activate or invoke system call, it will result in blocking of the whole process. तो उसको avoid करने के लिए you go for kernel level threads. Threads that are created at the kernel level, right, by the operating system, those are kernel level threads. So kernel level threads will manage the user level threads. Transparency will be gone. But it won't result in blocking of the whole process when one user level thread needs to go for IO operation or execute any system call. So relative comparisons है, आप देख सकते हो. So as far as basically threads are concerned, I would recommend that you basically try to focus on like what is the concept of thread, benefits of threads, मल्टी थ्रेडिंग के बेनिफिट्स क्या है, टाइप्स ऑफ थ्रेड्स, इतना देख लीजिएगा, दैट इज मोर देन सफिशिएंट इनफ फ्रॉम द एग्जामिनेशन पर्सपेक्टिव। और इसके बेसिस पर कुछ प्रैक्टिस क्वेश्चंस है, अपनी प्रैक्टिस के लिए आप सॉल्व कीजिएगा। दीज आर मोस्ट ऑफ द टाइम टेकन फ्रॉम द PYQ। लाइक एक सिंपल क्वेश्चन है, देखिएगा, थ्रेड्स ऑफ ए प्रोसेस शेयर व्हाट? इट शेयर बोथ हीप एंड ग्लोबल वेरिएबल। जस्ट नाउ आई मेड अ डिस्कशन, राइट। इसके अलावा लाइक दीज आर अगेन द डिफरेंट conceptual questions you can basically go through one by one and try to do the practice, ठीक है। So in addition to that, for your more practice, I have included further more practice questions. You take them and try to work out as a matter of practice on scheduling and memory के ऊपर है, semaphores के ऊपर है, synchronization के ऊपर है, and several other topic I have included some questions for you to practice. ये practice कीजिएगा, and in case if you have any questions, any doubt in any of these practicing questions or any doubt in any aspect of operating system, feel free to contact me at my Telegram channel, right? You can directly put that doubt in the channel, or you can DM me directly. I will be happy to respond to you. So thank you so much for patiently listening to my lectures. हमने महा रिवीजन, महा मैराथन कंप्लीट किया 3 सेशंस में, पार्ट 1, पार्ट 2, पार्ट 3। अगर आपने नहीं देखा तो देखिएगा। ये 3 parts will be definitely useful for your revision purpose. So thank you so much, and my best wishes for your forthcoming GATE exam. Thank you.